Yeah, so welcome to the ACE Conference 2014. I'm glad that you could all make it, and I know there's a lot of interesting presentations that are going to be made and a lot of interesting research and projects that we'll get to look at together. So just to begin with, I'm going to give a quick overview of the idea of how drawing relates to the practice of architecture and civil engineering. And this is especially important in our current time when we are faced with so many complex problems that are facing the world and that make it necessary to have a sort of broad, interdisciplinary, collaborative approach to design processes. And at the same time that that's happening, there's a certain amount of loss of clarity in the way that both the professions of engineering and architecture are able to work together in any sort of effective modes of communication, which should include drawing to a much higher degree. So I'm going to show a number of examples of historical precedents of drawing by architects and engineers and talk through a series of case studies about how drawing relates to the design, imagination, and production process working towards construction. So right now in the world, and this is especially important here in Asia, we have all sorts of complex pressures on the construction industry that we've never really had in the past. We're faced with very rapid urbanization, an unprecedented degree of change in the way people live, the density of the way people live, and the speed of construction. At the same time that we have this great need for new amounts of construction, we have increasing complexity in the technological possibilities, the range of modes of construction, production, fabrication that are available to us. We're also faced with an increasing need for affordability and economic efficiency in architecture. The resources are being stretched increasingly thin throughout the world, and we need to find much better ways of becoming efficient in the construction industries. At the same time, we have all sorts of pressures in terms of our environmental impact through construction on the natural world and on the urban world. So we have all sorts of issues of sustainability that we need to address that are quite vital for the future of human life and construction. So with all of that sort of complex pressure facing our industry, the construction industry and architecture and civil engineers, it's especially important that we start to work together much more collaboratively. We can't have these separate silos of different expertise in the field. We have to face these complex issues in a very interdisciplinary, interwoven sort of a process. And to facilitate that, we need to find ways to communicate with each other in the different fields. And part of that becomes more complex as our drawing methods through various forms of visualization, through different analytic software methods and modes of research practice actually draw us apart so that we tend to less and less understand each other in the different fields. So a sort of interdisciplinary approach to drawing is something that hasn't been thought about very much, but it's really essential that we start to understand visual means of communication between architects, engineers, builders, and the general public. So that's the kind of overall background for this talk. With this increased complexity that's facing our industries, there's an increasing need for this interdisciplinary collaboration through shared visualization. And we have a number of ways of doing this through analytic drawing, through sort of experimental, imaginative drawing, through technical drawing. But this, any of these methods require a great deal of sort of faith and shared respect across disciplines including allowing for a certain degree of experimentation and risk and a certain amount of projection of understanding of the possibilities that different areas of expertise bring to the table. So we have a general idea sometimes that architects are more on the design imagination side and the civil engineers are more on the technical sort of problem-solving side of the design process. But historically, that isn't always the case. Architects are very much involved in the technical production of the world, and engineers are very involved in the imaginative innovation side of the world. And to really harness all of that possibility between our fields, we need to work on some of these means of collaboration that involve experiment, suspension of disbelief about the initial origins of ideas, and a lot of sort of innovative, investigative processes of visualization and technical drawings working towards the production process. So as we work together in architecture and engineering from small research projects on very specific areas of study and on sort of broad imaginative ideas about how people will live in the world in terms of urban design and urban imagination, we have to integrate these areas of very fine-grained, deep technical knowledge into imagination about the broad issues of life in a impacted planet of very, very complex economic and environmental pressures. So as we bring these technical issues of construction, communication to bear on the imagination and projection of future possibilities, we can look back to quite a few precedents in the way that people have drawn and presented, communicated ideas about construction in the past. So I'm going to quickly show some of the kind of shared background of visual culture that we have as architects and engineers, from the sort of medieval drawings of cities, starting to understand how people have constructed things, to the, in this case, Piranesi's drawings of Rome, where we started to project backwards and understand the world and try to create a memory or a past-looking imagination of what classical cultures produced as cities. And then this is the famous Noli plan in Rome, one of the kind of seminal tools in the understanding of the way cities are conceived and constructed. So, and these ideas then, through drawing, that have been visualized in drawing and that have brought tremendous new insights to understanding of human culture and construction, have then brought forward a whole range of different ways that people have tended then to draw the environment and experiment with drawings about the environment, trying to get at a whole range of ideas, from the kind of technical idea of construction of cities to the social and cultural issues of the city, to very spatial understandings of the way all of these conceptions of our life in cities start to impact both the technology. So we see here a real compaction of technology and its understanding in the broader human conception of space and life. So from the 20th century drawings of Constant, John Haydock, Lebbeus Woods, we have all sorts of examples of very experimental drawings about life in the city, possible understandings of the way cities impact our world and relate to our life. And then we have increasing experiments in more technical understandings of analytical software as applied to regional planning and urban planning, so that we can start to layer up many different understandings into complex digital models. In the history of the drawing of technology, we have all sorts of fantastic examples of ways that designers, builders, fabricators of things have communicated with each other and communicated to the larger public about what technology means in terms of production and in terms of the way that we interact with it. And a lot of these examples from other fields outside of architecture and engineering tend to be much more directly accessible to the general public. And this is one of the areas in which current practices of architecture and engineering really fail to connect with the larger world, and to fail to connect and make people, the broader public, understand how complex the issues are, why technological change is required, why different construction methods are significant in different ways for different purposes. And we don't really have a means of communicating these sorts of technological issues in civil engineering and architecture in the same way that people have experimented with them in other areas of design. So in the history of engineering drawing, there are these quite amazing drawings, cutaway views, transparent views, technological overlays of different components at with different emphases, so that we can see the whole idea and we can zoom in down to the smaller pieces. So these are techniques that we largely don't use anymore. So this is an example of the sort of artist's conception of engineering drawing that we saw more in the 1950s, for example, where there was a great deal of public interest in engineering technology and in the idea of what the new possibilities of life and technology would mean. But again, there's less and less of this sort of drawing that is somehow accessible both across fields and to the general public. So we have all kinds of these great examples. And then as we move forward, there are examples from other fields. This is a section through a cooking pot that shows us using photography and digital image making, we start to be able to use ways of visualizing information that, again, is typically outside of our general use of drawing and visualization in architecture and engineering. So as we come more towards building construction, we have some really interesting use of three-dimensional visualization and construction drawing. Again, typically not the sorts of things that are done for building construction, but more in allied industries. But increasingly, there are construction drawings, civil engineering drawings, architecture drawings that are really starting to use some of these other fabrication and engineering types of visualizations in the construction drawing process. So we have a lot of experiments in the way that we can show more technical information and visualize it in a variety of different ways through digital modeling, and then taking apart the models, getting down into the actual fabrication details. And both at the same time that we're able to zoom in, we're able to zoom out and start to look at the way buildings are becoming extremely complex systems with all kinds of simultaneous technologies operating within them, which of course is a complexity in construction, but we also, through drawing, have these visualization and clash detection and digital modeling, building information modeling tools that start to make construction drawings and construction processes that we employed in the past shift into a quite different sort of integration of drawing and fabrication. So at the same time, we have this range of drawings that are related to ways of communicating ideas. There's the other aspect of drawing that is quite neglected as a practice in engineering especially, but also in architecture, and that is the sort of investigative drawing, the experimental drawing that starts to try to look for an idea through drawing or explain, understand an idea before it's fully understood by the maker of the idea, before it's fully understood and ready to be communicated. There's the need to work towards innovation. And this requires experimental drawing through a variety of different means, from digital modeling and experimentation to the old-fashioned hand drawing methods, where we have to provide space in our practice of architecture and engineering for these sorts of experimental drawing methods, where we don't yet know exactly what the issue is. We don't know exactly what the idea is for how these things will be employed or how they will be built, how they will be communicated to the fabricators. But first, we have to get out on the table a whole range of ideas and experiments and make these available for cross-disciplinary discussion, for imagination, for understanding of issues of motion, time change, spatial relationships. And this is another thing that in the history of drawing practice, the history of architecture and engineering, is an essential tool that we can't neglect in our rush to digital modeling, for example. We still have to work on these much more experimental processes. So I'm going to show you now in my own work a series of case studies, my own work, my work with my brother Peter in our construction firm, and with other people like Vir Alshat, who's in the room, work with people in different places. Case studies emphasizing the drawing process in the process of shifting from idea into production. So this is a very quick case study in a small house in Palo Alto, California, in the United States. It's a modular building that's built in a factory, and to work towards increasingly efficient modes of construction requires a different understanding of the sorts of drawings that are required in the process and the different means of communication. This becomes more clear. This is a project for Harvard University, a small classroom building that was a very low cost, very high speed construction process, about 6 months design and construction. A modular building that was built halfway across the country, had to come together in pieces. So again, the drawing process is very different in working with manufacturing contractors as opposed to general contractors. There's different forms of visualization techniques and a real emphasis in the process, not only on the process of construction, but to facilitate an efficient process of construction, needing to zoom into details and show these details not just in the more typical construction document approach, but in showing people who aren't always used to those documents alternative means of visualization where you really get into exactly how things come together, the order of fabrication, the overlapping elements, so that everything can be conceived, drawn, and then fabricated as a holistic process. So these are relatively simple buildings, but they have a fair number of complex parts that through drawing can be brought straight into fabrication processes, straight into some digital fabrication, and then pulling diverse elements together and excuse me, bringing the modules of drawing into the modularity of fabrication, bringing this all together into a completed process. One of the important elements in that is the early analytic software that focuses on the environmental impact and the environmental relationships in the building processes. So this process of shifting now to a small classroom for the state of Hawaii in the United States. This is a net zero energy modular building. It was a complex design build collaboration between a number of different firms. So there's a lot of visualization just of the process of collaboration. And then back into these issues of, even with modular construction, trying to get into very site-specific ideas about how the environment impacts a building, and especially in a net zero energy type of application, it's essential to use analytic software to model in advance the interaction of the building in relationship to the specific environment that it's working within. So being able to then recognize the sort of complex relationships of the natural environment, the urban environment, the context that impacts a building involves being able to visualize that, being able to make this a part of the drawing process, not just through technical drawing of the conventional sort, but trying to figure out how do we draw sunlight, how do we draw wind flow, how do we draw rain, how do we draw daylighting. All of these issues going from the analytic software into diagramming into then the fabrication drawings is an essential way to bring these larger environmental issues into the understanding of how to build the process as a construction process. So this means a lot of emphasis in our current drawing world on analytic software, which opens up an entirely new sort of drawing world for architects and engineers. And there's been a lot of advance in the last 20 years in our ability to visualize well, it's physical, definitely physical phenomena such as wind and sun and so forth, but it's not the stuff that we typically draw, yet it is the basic sort of environmental context that we build within. So these new softwares that not only are able to quantify the natural phenomena around us, but they are also able to visualize that, make it apparent and obvious for not just technical specialists, but also for designers working on a variety of different issues. This opens up enormous new possibilities for the way that architects and engineers work together to visualize phenomena and then to apply it in the design of structures. So this sort of process is also brings us to the idea of design drawing as a very facile way to start to show how buildings can adapt to different sorts of contexts and conditions. So this is essentially the same building. In this case, it's adapted for the environment of California. It becomes a very different building. And then through, even within a sort of modular process of construction, we can start to modify elements and through drawing very quickly start to visualize different sorts of possibilities within a sort of common language that has a good deal of adaptability within it. These are examples of projects with students that are focused on, these are projects at the University of California, Berkeley, where the students are working on learning about processes of construction through digital modeling, through drawing, through model making, through full-scale prototyping, all as one continuous process from drawing through making. And ultimately, that's what all of us are interested in, not drawing and design as a separate sort of process, but instead drawing and design moving through fabrication, through the construction process. So this sort of integration of drawing and making is essential in the way that I think about teaching students. And it brings together a lot of these issues of what the potential of our field really opens up for us. And that is to start thinking, as we have new opportunities for much denser cities, as we have the need to build rapidly with denser cities, we have to also emphasize high qualities of life, high qualities of sustainability, high quality of integration with natural environments. And to accomplish this, it requires a great deal of design imagination on the one hand, a great deal of analytical research on the natural phenomena surrounding a building, the airflow, the sunlight, the daylight, all the effects that are critical to our quality of life in the natural world, even when we're in a constructed world. And then bringing these to bear through digital drawing into visualization of very particular social structures and integrations to make a high quality of urban life. And then zooming back into the construction details that facilitate what is possible for doing these sorts of construction projects with great efficiency and affordability. So a lot of times as architects and engineers, we think that first of all, we are figuring out technical details. We're working up towards the building then works up and becomes part of the city. But increasingly, in a world where everything is so interconnected, we can no longer work in this sort of a linear path. Instead, we have to use drawing, analysis of the world through analytic software to first look globally at the way we want our cities to be built, what kind of life we want to have in the world. And then we have to start to work backwards and say, if we want to build sustainably, if we want to build efficiently, affordably, if we want to have people enjoying their terrace, their home, they have a good quality of life. If we want to achieve that, then we work backwards. What is the technology that we need to invent, to design, to put together, to integrate in order to create these possibilities? And of course, these are not linear either from the technical detail up to the city or from the city in a linear way down to the technical detail. Actually, it's a cyclical process, as we all know. It's an iterative process of design where we're working simultaneously with the details and with the large-scale urban design plans and trying to integrate all of these through digital drawing, through imaginative hand drawing, trying to figure out ways that we can imagine alternatives to the way that we are doing things now, thinking about alternative ways to interact with the natural environment and to create new qualities of life, and to experiment with these things through drawing, through detailing, at multiple scales simultaneously. So to do this requires both the digital drawing, the hand drawing, the model making, the large-scale prototyping, and most important, it requires a great deal of imagination, interdisciplinary collaboration between engineers and architects, and a lot of faith in the imagination and the kind of technical possibility of drawing to open up new worlds for our disciplines. So with that, I'd like to thank you again for all being here.